In this software movie, we'll take a little bit more in-depth view at some of the Spectra Tools capabilities. These are found in the Spectrum Tools area located in the upper right of the Spectrum window. To get at this panel, I simply hover my mouse over the area, and if I want to keep it out, I click on the triangle, and then the window will stay out. Each of the sub-areas of the panel could be contracted or expanded depending upon which area you'd like to work with. We'll start with the top, and we'll go over the most commonly used functions. You could load a spectrum, any .spc file that was collected with any EDAX software. This simply allows you to load the file with common Microsoft convention by doing a load and then opening up the file type. You could also save directly as an SPC file here as well. Clicking on the Add will allow you to add Spectra on top of one that's already opened, and Clear allows you to clear the Spectra out for a fresh window. The opacity lets you see behind the Spectrum window, so if you have an image behind your window, you could lower the opacity and see your image or your area of collection located behind the spectrum. Changing that will change the view. Genesis Mouse allows those familiar with the Genesis software to use a left mouse click and drag to expand and contract the spectrum. Autoscale is used when you have two or more spectra overlaid, and they'll autoscale to the highest peak. Overlay mode allows that to be activated. In the Element ID area, we have several options available to us. Expert ID is at the core of our data analysis and our peak identification. Showing Element ID will allow you to see the elements that have been selected with the Expert ID process. Showing Sum Peaks allows you to activate where potential sum peaks will occur. And you can see on my spectra, as I toggle on and off, those sum peak markers appear and disappear. Likewise with escape peaks. The limit to quant labels is a useful function for removing too much clutter or appearance to your spectrum. For example, sometimes you have more than one element line, for example, silver L and silver M, and this might appear cluttered down here at the low end. If I want to clean that up, I just activate that, and then I have my primary peaks that will be used for quantitative analysis labeled. The label sensitivity controls how much detail is provided with any element peak. First, removing the limit to quant labels, and then changing the label sensitivity allows me to change the display. Pay attention to this silver area, and as I lower that label sensitivity, it reduces the number of peaks that are identified. Likewise, if I have high sensitivity, it has all those peaks. Another really neat function is if you zoom in on an area and look at those peaks, they'll give you more information about the peaks the more zoomed in that you are. And if you zoom out, eventually those peaks lower down, that number of peaks lowers down. The ID sensitivity is the sensitivity at which it actually identifies the peaks. Higher sensitivity means more peaks will be identified. Lower sensitivity means less peaks will be identified. Do Element ID simply enacts the process all over again. Background can be done with numbers here in this area, manually, or with the background correction area, as we saw in an earlier software movie. The deconvolution allows you to change the view of the deconvolution line, whether you have it shown or not shown, as well as the colors and the thickness of the line. There are a lot of quantitative options with the EDAX Team EDS software. The default method is EZAF. We also provide PBZAF, and that allows you to work with rough surfaces, particles, say fracture surfaces, non-typical sample types. MThin allows you to work with thin samples using a different process. The details of the quantitative analysis will be reserved for the quantitative movie. Processing allows us to explore some of the advanced capabilities of the software. There are known artifacts in any EDS spectrum. We're able to correct for them, so things like escape correction, we're able to remove the effects of the escape peaks. Likewise with incomplete charge, a known phenomenon that occurs in the EDS spectrum where the low end will have a tail, the ICC correction will help remove the effects of the tail, and the shift correction will help shift the spectrum back based on truly where the peaks fall rather than the theoretical. When you have the smart pileup consideration activated, you can do a full pileup correction, which will anticipate the amount of pileup that has occurred, as well as correct the spectrum. Spectrum overlay math allows you to have more than one spectra activated, where you could add or subtract spectra one from another. Finally, one of the most important areas is the file parameters. It's important to make sure that your file parameters are always being read from the microscope and that they are proper. Often this is good for troubleshooting. Say, for example, if something is different than what you anticipate, this is a quick way of referencing to make sure the collection conditions were proper.